Hello, student. Today we are starting our lecture with the previous discussion. That in previous lecture we will see that the how we can control the LED by using the Raspberry Pi. So in this lecture we will see programming that we done in the Raspberry Pi for the controlling the GPIO pin and particularly to control the LEDs. Okay, so first we write that import rpi.gpio GPIO as a GPIO. So it will import the it will make the use of GPIO pin, and then we write that the import time, so we can, if we want to add some time delays, then we can add it. Okay, so then we write the GPIO dot set mode, GPIO dot board, then we write the GPIO dot setup 7 GPIO dot out. So we make the pin 7 as a output. Then we write the GPIO dot output 7 is a true, then it will turn on, or we can say that it will hide the pin. Pin number 7 will be high. Then if we write the time dot sleep is 1, then it will create a 1 second delay. Then if we write the GPIO dot output 7 is false, then it will turn off or make a lower the it will lower the pin number 7. Then again we write the time dot sleep is 1, then again we write the true, then false. Then what will it do, that it on the LED for 1 second, then turn off, then turn on, turn off, then turn off. So it will create a blinking effect. Okay, so then print done, so it will print the done, and GPI dot cleanup. So this is the basic program to on and off the LED. But Raspberry Pi is not just for the on and off the LED. It has a many useful things, or many productive things that we can do on the Raspberry Pi. Okay, so task 1 is the turn on LED for 2 seconds and off for 1 second and loop forever. So we can write a code. So uh, we can write one code that will turn on the LED for 2 seconds and off for 1 second. Okay, so in this example we use the diagram B and controlling the LED by controlling the voltage at the anode. Okay, so import RBI dot GPIO as GPIO, then import time. So then define main. So we define one main program, GPI dot cleanup, then dot set mode, GPIO dot board. Then we use the GPIO 11. Then while true, so we use the while loop. While true, GPIO output 11 dot GPIO low, and time sleep for 1. Then we will after 1 second we will do that the 11 number pin is high, and we create the time sleep dot sleep for a 2 second. And then we write the main, so it means that it will again go up. Okay, so what will this main do, it will again go up and follow this same code. Okay, so what will do that, it will off the LED for 1 second and on the LED for 2 seconds. Okay, so this is how we can uh, do the some simple task on the Raspberry Pi. Okay, then example, a display a digit on a 7 segment LED. It is most direct way to control the display. So connect pin 3 or 8 of 7 segment LED to the VCC. Okay, so we can control the 7 segment display by using the Raspberry Pi. Okay, so connect the other 8 pins to the 8 GPIO pins and configure the 8 GPIO pin as out. And then, for example, if we want to display the 2, then turn on the segments A, D, E, G. Okay, and turn off the other segments. Okay, so whatever we want to display on the 7 segment, only that particular LED we will on, and our display will display the digits. So we can easily do such things by using the Raspberry Pi. Okay, So interfacing an LED and switch with the Raspberry Pi. So now we don't write a code only that we on and off the LED by automatically. Now we use the switch. Okay, so when the switch is not pushed, GPIO detects VCC high, and when switch is pushed, GPIO detects a ground. Okay, so GPIO input sample code. So now we have a input also. So we make one pin as a input and one pin as a output. Okay, so GPIO dot input is 17. So 17 number pin is our input pin, and we connect the LED with some other pin. Okay, so we can on and off the LED by using that switch. Okay. So now we interface the our light sensor. Okay, so unlike some other device, the Raspberry Pi does not have any analog inputs. So all the 17s of its GPIO pins are digital, so they can output high or low levels or read the high or low levels only. So uh, Raspberry Pi doesn't have any analog pins. Okay, so for the sensor that act as a variable register such as a LDR, light dependent registers or thermistors, there is a simple solution. It allows. Okay, so now we will discuss one new topic, implementation of IoT with the edge devices. An edge is a device that provides an entry point into the enterprise or a service provider core networks. Examples include the routers, routing switches, integrated access device, IADs, multiplexers, and variety of metropolians aerial network, man wide area network, WAN access devices. Okay, so edge device also provide connection into carrier and the service provider networks. An edge device that connects a local area network to a high speed switch or a backbone may be called the edge concentrator. Okay, so edge device is a device which produces data in edge devices like machines, sensors, or any devices through which information is collected and delivered. Okay, so then we have a edge gateways. It's a buffer where edge computing processing is done. The gateway is the window into the environment beyond the edge of the network. Then we have a edge computing, aims to speed up critical data processing closer to where the device is located. It implies that data processing is done more efficiently. There is no need for centralization of attributes. In other words, we can say that the edge computing is a mesh interface to process and store micro data centers locally. Okay, so one of the most common type of edge devices is a edge router. Okay, so usually deployed to connect a campus network to internet or a WAN. Edge routers chiefly function as a gateway between the networks. Okay, so firewalls can also be classified as the edge devices, and as they sit on the periphery of the uh, one network, filter data moving between internal and external networks. So edge devices are comprised of hardware that perform the two essential function of providing physical connectivity and enabling the traffic between network. Okay, so a full range of edge device functions might include the transmission, routing, processing, monitoring, filtering, translation, and storage of data between networks. Okay. So edge computing was developed due to the exponential growth of IoT devices which connect to internet for either receiving information from the cloud or delivering data back to the cloud. And many IoT devices generate enormous amount of data during the course of their operation. Okay, so data produced by the IoT devices to be proceed where it is created instead of taking away to the routes to data centers with the help of edge computing. Okay, so why edge computing matters? So when IoT device have a poor connectivity and not efficient for IoT device to be constant touch with the central cloud, then in that condition we use the edge computing. Okay, so the latency factor reduces the latency because data does not have to transfer over a network to a central cloud for processing. Okay, so where latency are undeniable like manufacturing or financial services. So as soon as data is produced, it doesn't need to send over the network. Instead, it compile the data and sends daily report to the cloud for a long-term storage or reduces the data transmission. Okay, so direct access to a gateway into telecom provider networks which connects to the public ISS cloud provider. Okay, so this shows the some edge centering IoT architecture. So this is a cloud user interface, edge user interface. This is the edge where all the devices are interconnected. Okay, so edge-centric IoT architecture consists of four major parts: the cloud, the IoT and devices, the edge and user. Okay, so the IoT and devices are deeply embedded in a physical world, and they sense the physical world and take the action to control the physical world. Sorry, an age centric IoT architecture. IoT users submit queries to access IoT data or commands to control IoT devices. These queries and commands will eventually arrive at the edge layer through a web or a mobile app based interface provided by the cloud or the edge. Okay, so then they are handled by the edge layer who will either forward them to the IoT and devices or handle them at the end at the edge layer on the behalf of IoT and devices. Okay, so interacting with IoT and devices, the edge layer not only bridges them with the user and the cloud, but also can store the data collected and uploaded from IoT and devices and offload the substantial computational needs such as a big data analysis. Okay, so in addition, many existing services for IoT and devices can be migrated from the cloud to the edge and can be customized based on the needs of IoT and services. Okay, so this is for the edge centric devices and IoT architecture. So how we use the edge centric services for the IoT shortcomings. Okay, so this is it for today, and we will discuss further reading how we read the sensor data and transmit to the cloud. Okay, so in next lecture we will see all these things. Okay, so if you have any kind of doubt up to now, then you can comment it down, and don't forget to comment your enrollment number and name in the comment box, so it will count as your online attendance. Okay, uh, thank you.